Preparing for a senior software engineer interview at Gallagher Interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Tell me about yourself and your experience as a senior software engineer. I am a software engineer with several years of experience designing, building, and supporting production systems. My recent work has focused on back-end services, cloud platforms, and improving reliability through automation and observability. In senior roles, I have owned architecture decisions, mentored engineers, and partnered closely with product teams. One example was reducing a critical workflow's processing time by 40% while improving monitoring. I am now looking for a role where technical quality and meaningful business outcomes are equally important. While answering, focus on your technical progression, ownership of production systems, leadership without formal authority, measurable outcomes, and experience collaborating with product, operations, security, and business stakeholders. Question 2. Why do you want to work at Gallagher? Gallagher appeals to me because technology directly supports risk management, client service, and operational efficiency across a global business. That creates interesting engineering problems where reliability, security, and data quality matter every day. I am especially interested in contributing to modern platforms while respecting the stability required in an insurance environment. My background in scalable services, automation, and cross-functional delivery fits that balance. I also value organizations where engineers can grow, collaborate broadly, and take ownership beyond simply writing code. Make sure to cover Gallagher's insurance and risk management mission, the importance of dependable technology, opportunities to modernize platforms, and how your skills align with collaboration, customer impact, and long-term engineering ownership. Question 3. Describe a system you designed from the ground up. I designed a document processing service that accepted uploads, validated metadata, extracted information, and published results to downstream applications. I chose an API with asynchronous queue-based processing because workloads were variable and some extraction steps were slow. We stored documents in object storage, tracked workflow state in a relational database, and added idempotency keys for safe retries. I also defined access controls, monitoring, and failure queues. The system handled peak volume without blocking users and reduced manual processing substantially. In your answer, talk about requirements, constraints, architecture choices, data design, scalability, security, deployment, testing, trade-offs, and how you measured whether the finished system met its objectives. Question 4. How would you design a highly available service for processing insurance-related transactions? I would begin by defining transaction criticality, recovery objectives, and acceptable consistency behavior. I would deploy stateless service instances across availability zones behind a load balancer, use durable transactional storage with replication, and isolate slow work through reliable queues. Every request would carry an idempotency key so retries cannot create duplicate transactions. Health checks, tracing, alerts, and tested failover procedures are essential. I would also protect sensitive data through encryption and least privilege access, then validate the design with load and chaos testing. Be sure to mention availability targets, redundancy, stateless services, durable storage, queues, idempotency, retries, observability, disaster recovery, security, and the trade-off between consistency, latency, and operational complexity. Question 5. What is your approach to breaking a monolith into microservices? I do not split a monolith simply because microservices are fashionable. I first map business capabilities, deployment pain points, ownership boundaries, and runtime dependencies. Then I select a bounded capability that has clear interfaces and meaningful operational benefits. I introduce an anti-corruption layer, define API contracts, establish independent observability, and migrate traffic gradually. Data ownership requires particular care, so I avoid premature duplication and use events or controlled synchronization where appropriate. Each extraction should reduce risk or improve scalability measurably. Focus on identifying business boundaries, understanding dependencies, selecting an incremental migration path, preserving contracts, managing data ownership, measuring benefits, and avoiding microservices that add complexity without solving a real problem. Question 6. How do you ensure code quality on a large engineering team? I treat code quality as a system rather than a final review step. Teams need clear conventions, focused design discussions, automated unit and integration tests, static analysis, and a dependable C pipeline. Reviews should examine correctness, maintainability, security, and operational impact, not personal style. I also favor small pull requests and production telemetry that exposes defects quickly. For risky changes, feature flags and staged releases reduce blast radius. The goal is fast, repeatable delivery with quality built into the workflow. Mention coding standards, design reviews, automated tests, static analysis, peer review, continuous integration, deployment controls, documentation, production feedback, and a culture that improves quality without creating unnecessary process bottlenecks. Question 7. Explain how you would troubleshoot a sudden production performance degradation. I would first confirm the scope, timing, affected endpoints, and customer impact using dashboards and alerts. Next, I would compare the incident with recent deployments, traffic changes, infrastructure metrics, database behavior, and external dependencies. Distributed tracing helps identify where latency increased, while logs validate the leading hypothesis. I would communicate status clearly and apply the safest mitigation, such as rollback, throttling, or scaling. After recovery, I would complete a blameless review and implement a durable corrective action. In your answer, describe symptom confirmation, recent change analysis, metrics, traces, logs, dependency checks, hypothesis testing, mitigation, communication, root cause analysis, and preventive actions after service restoration. Question 8. How do you design secure applications that handle sensitive customer data? I start by classifying the data and identifying who should access which actions. Authentication should use established identity services, while authorization should enforce least privilege at every relevant boundary. Sensitive data requires encryption in transit and at rest, with secrets stored outside source control and rotated regularly. I include dependency scanning, input validation, threat modeling, audit logging, and security testing in the delivery pipeline. Finally, I minimize retained data and ensure alerts and response procedures exist for suspected misuse. Be sure to cover data classification, least privilege, authentication, authorization, encryption, secrets management, secure development, logging, vulnerability management, privacy requirements, and incident response preparation. Question 9. What is your experience with cloud architecture in deployment? My cloud experience includes deploying containerized services, managed databases, object storage, queues, monitoring, and identity controls. I prefer infrastructure as code so environments are reproducible and changes are reviewable. A typical pipeline builds artifacts, runs tests and security checks, deploys to a non-production environment, and promotes approved versions gradually. I pay attention to networking, permissions, cost, and recovery rather than treating the cloud as an unlimited resource. Good cloud design combines automation with clear operational ownership. Talk about the cloud services you have used, infrastructure as code, networking, identity, containers or serverless platforms, CD, observability, cost management, resilience, and how you chose services based on requirements. Question 10. How would you design an API for a new business capability? I would begin by clarifying the business workflow and identifying whether consumers need synchronous responses or asynchronous completion. I would define resources, state transitions, validation rules, authorization boundaries, and consistent error formats before implementation. The API should support pagination, correlation identifiers, idempotency for writes, and an explicit versioning strategy. I would publish an accurate contract, generate tests from it, and measure usage and failures. Designing for backward compatibility matters because APIs become dependencies long after their original launch. Focus on understanding consumers, defining resource and workflow semantics, choosing HTTP behavior, validation, versioning, pagination, errors, security, idempotency, documentation, observability, and compatibility over time. Question 11. How do you handle database design and performance optimization? I begin with access patterns, consistency requirements, data relationships, and expected growth. For transactional workflows, a relational model is often appropriate, with indexes designed from actual query patterns rather than added indiscriminately. I inspect execution plans, measure slow queries, and consider caching or read replicas only after understanding the bottleneck. Schema migrations must be backward compatible and reversible where possible. If scale or access patterns justify another model, I document the trade-off clearly instead of choosing technology by preference. Mention access patterns, normalization, indexing, transaction boundaries, query plans, data growth, caching, partitioning, concurrency, migration safety, monitoring, and selecting relational or non-relational storage deliberately. Question 12. Describe a time you disagreed with an architectural decision. A team once proposed synchronous calls between several services for a workflow with unpredictable processing times. I was concerned about cascading timeouts and poor resilience, so I documented the failure modes and compared an asynchronous option using realistic volume assumptions. We discussed the trade-offs openly and agreed to use asynchronous processing for the long-running steps while keeping a synchronous acknowledgement for users. The decision improved reliability without overcomplicating the interface. I supported the final design and helped monitor its results. In your answer, show respectful challenge, evidence-based reasoning, listening, decision ownership, compromise, delivery focus, and what you learned regardless of whether your preferred design was adopted. Question 13. How do you mentor junior and mid-level engineers? I tailor mentorship to the engineer's goals and current level. Early on, I pair on problem decomposition and explain why I make particular design choices. Code reviews focus on principles and alternatives rather than merely correcting syntax. I then give progressively larger ownership, such as leading a small feature, presenting the design, and handling operational follow-up. Regular conversations help identify blockers and career goals. Effective mentorship should increase independent judgment, not create dependence on the senior engineer. Be sure to mention individualized coaching, thoughtful code reviews, pairing, explaining reasoning, progressive ownership, psychological safety, feedback, measurable growth, and balancing mentorship with delivery responsibilities. Question 14. Tell me about a failure or mistake and what you learned from it. I once approved a deployment whose migration worked in testing but caused lock contention under production volume. I helped roll back safely, communicated the impact, and participated in the investigation without shifting blame. The deeper issue was that our test data and migration checks were unrealistic. We added production-scale performance tests, migration time limits, safer expand and contract patterns, and a deployment checklist. That experience reinforced that database changes deserve the same operational discipline as application code. Focus on accountability, the technical and process cause, impact, immediate response, prevention, stakeholder communication, and evidence that your behavior or system improved afterward. Question 15. How do you prioritize technical debt against new feature delivery? I translate technical debt into consequences stakeholders can understand: slower delivery, incident risk, cloud cost, security exposure, or customer friction. I then rank it against feature value and commitments, using evidence such as incident frequency or cycle time data. I prefer incremental remediation, for example improving a heavily changed module while delivering adjacent functionality. For serious risks, I propose a time-bound plan with milestones and success measures. This makes debt a business decision rather than an abstract engineering preference. Talk about customer and business impact, reliability risk, engineering capacity, measurable cost, sequencing, stakeholder alignment, incremental remediation, and distinguishing urgent architectural risks from ordinary maintenance. Question 16. How do you test distributed systems and asynchronous workflows? I use multiple layers because no single test type captures distributed behavior. Unit tests cover local rules, contract tests protect service boundaries, and integration tests validate queues, databases, and authentication together. I specifically test duplicate delivery, out-of-order events, timeouts, partial failures, retries, and poison messages. For critical workflows, controlled end-to-end tests run with production-like data volumes. Observability is part of testability. Correlation identifiers and state transitions make failures diagnosable. I also use targeted fault injection before major releases. Mention unit, contract, integration, end-to-end, failure injection, duplicate messages, ordering, retries, timeouts, eventual consistency, observability, test data, and production-like environments. Question 17. How do you respond when product requirements are unclear or changing? I first clarify the customer problem, desired outcome, constraints, and definition of success rather than jumping straight to implementation. I write down assumptions and open questions, then propose a small slice that can validate the highest risk behavior quickly. As requirements change, I explain effects on scope, design, timeline, and operational risk in clear language. I keep decisions visible and revisit them when evidence changes. This approach preserves flexibility while preventing ambiguity from becoming hidden rework. In your answer, discuss clarifying outcomes, identifying assumptions, documenting decisions, separating must-haves from options, validating early, managing scope, and communicating technical consequences of changes. Question 18. Describe a time you led a project without being the formal manager. I led a platform migration involving engineers from application, infrastructure, security, and support teams. I created the technical plan, clarified ownership, identified dependencies, and established weekly risk reviews. Rather than making every decision myself, I asked subject matter experts to own specific workstreams and documented choices for transparency. When a dependency slipped, we replanned around a lower risk sequence and communicated the impact early. We completed the migration with no major outage and improved deployment consistency afterward. Be sure to cover vision, planning, stakeholder alignment, delegation, risk management, conflict resolution, communication cadence, delivery results, and how you enabled others rather than doing everything yourself. Question 19. How do you balance delivery speed with reliability and maintainability? I separate speed from recklessness. Small increments, automated tests, feature flags, and staged releases let teams move quickly while keeping changes reversible. I apply deeper design and testing where data integrity, security, or customer continuity is at stake, while avoiding unnecessary ceremony for low-risk work. Every service should have ownership, monitoring, and a recovery path before it becomes critical. When a shortcut is necessary, I document the debt, assign follow-up ownership, and make the trade-off visible. Focus on risk-based engineering, small increments, automation, observability, reversible releases, quality thresholds, operational ownership, and explaining when speed creates future cost or unacceptable customer exposure. Question 20. What questions would you ask us at the end of the interview? I would ask which technical and business outcomes the team is prioritizing over the next 6 to 12 months, and how success is measured. I would also explore the current architecture, biggest reliability or scalability challenges, deployment practices, and expectations for production ownership. Understanding team collaboration and decision-making is important to me, so I would ask how engineers work with product and security partners. Finally, I would ask what distinguishes someone who performs exceptionally well at Gallagher in this role. Mention questions about team structure, engineering priorities, architecture, delivery practices, production ownership, success measures, career development, Gallagher's transformation, and challenges the new hire should address first. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.